So here's the first type of question where we're really going to have to take what we learned from chapter 15 and apply it to chapter 16. So we're asked about these two things mixing together and then wondering, are we going to have more products or more reactants? Okay, so that is an equilibrium concept, and then we're going to apply it to acids and bases. To answer this question, you have to have this image, and you'll have that embedded in an exam question. So let's look at this first option here, okay? So when F minus and HCO3 minus are mixed, will equilibrium favor the reactants or products? Okay, so I've really pared this down and because I wanted to force you to write what is this going to do in solution. Okay, so F minus, and I should have said that all of these were aqueous. Okay, plus HCO3 minus. Those are the two things that we've mixed together. So what products would we form? What are we thinking that might happen? Well, F minus is going to have to accept that H. Okay, so we're doing acid-base chemistry here, so don't try and do anything other than just transferring a proton. Okay, so I'd have HF and CO3 2 minus, right? Because this F minus, the only thing it can do, it can't give a proton, so it must be acting as the base. It's going to accept it. So this was acting as our base. Here's its conjugate acid. So these two are connected. And then here's our acid. It's donating our proton. And then there's its conjugate base. Let's write this over here. To decide if we are going to favor reactants or products, we need to compare the strength of the acids or the bases, okay? And equilibrium, our rule here, let's write like really big. The rule is that in an acid base, equilibrium favors the weak, we'll say favors the side with the weak acid and base, okay? That's necessarily they're going to be on the same side. I'm not going to have the strong acid and weak base on one side. That's not how this is going to work. You could piece that out from the like sort of reciprocal nature as the strong, like the stronger the acid, the less strong its conjugate bases, but this is always going to be true. There's never going to be, as soon as you identify where the weak base or the weak acid is, that tells you what side you're going to be on. Okay, so I'm going to grab, in this case, let's do the acids. Okay, I'm going to compare the strength of HCO3 minus. Okay, that's the acid moving in the forward direction. If I was going to think about this going in the backwards direction, HF is my acid. So I need to look on my graph, on my graphic, and find those two species. So here's HF, and HCO3 minus is all the way down here. So on the acid side, higher up, that is the stronger acid. So HF is stronger and HCO3 minus is weaker. Okay, so I must be on, my equilibrium is going to favor the left side, which are my reactants. So if I were to mix these things together, this reaction doesn't happen all that much. I'm going to have a K less than 1. All right, so in this case, this should be reactants. All right, let's do it again. Okay, this one should feel, actually the first one I gave you was the most challenging. You could look, I think, at these next two and feel pretty comfortable making a decision rather quickly, just because you know HCl is a strong acid and HS minus is not, like HCl is a strong acid. So I'm going to really guess that it's going to give away its proton. It doesn't actually want to keep it, right? So I'll still go through the process. HCl is going to give its proton to HS minus. Okay, so I'm going to have Cl minus and H2S. So this was my acid. This acted as my base. This then is my conjugate base. And this is my conjugate acid. So I can then find, let's do base this time. We're going to compare HS minus to Cl minus. So because HCl is such a strong acid, its conjugate base is very weak. It's a negligible base. It's like, I shouldn't even call it a base. It's never going to take a proton. That's all the way up here. So this is incredibly weak. Whereas HS minus is right here. Okay, it's a weak base. So this is a weak base, but this is a negligible base. And so negligible is much weaker than a weak base. So I am going to, in this case, favor products. And K would be greater than 1. Okay, so this one is products. And then lastly, we have OH minus plus CH3 COO minus. Okay, and we are going to have HCH3 COO minus take a proton from, sorry, are we going to do that? Yeah, we are. We're going to have it take a proton from OH minus. I can't, these are not acidic protons over here, so can't do that. Okay, so we're going to make O2 minus plus CH3COOH. Okay, and so then this should be like, whoa, that is a really, really, really strong base. It seems unlikely that we're going to favor that side. Okay, so this is, let's see, this is acting as our acid. Okay, the fact that I'm writing that OH minus is going to be our acid should like raise alarm bells. That doesn't seem like what it's going to do. It usually is going to act as a base. But the way that I wrote this, the two things I put together, that's the only way that this could move. Like, that's the only logical way to move this forward. These are not, those protons don't get involved with proton transfer reactions. Okay, so this must have acted as our base. Okay, so then this is our conjugate base, which is really strong. And this is our conjugate acid, which is a weak acid, but it is a much stronger acid than this OH minus. So in other words, if I put these two together, I am never going to expect this to move forward, right? Because this is not going to take a proton from OH minus. Or I could think about it, if I put these two together, this O2 minus is immediately going to rip the proton off of that. Okay, so this is my strong base on this side and my strong acid, relatively speaking, to what was our acid and base on the reactant side. You can also go up. We could pick, let's not pick that one. Let's pick our bases, these two. Okay, so there's O2 minus, okay, and there's CH3COO minus. That is a much stronger base on the product side. So we should really not move forward on this at all. Reactants are favored, which I could also have written as K being less than 1.